All right, guys. So again, we're reviewing some rules that you already know. I'm going to go over those rules pretty quick. And for the most part, we're just going to do a whole bunch of examples using those rules. They're rules that you've done in 8th and 9th grade. Now we're just making the problems look a little bit more difficult. Maybe some extra numbers, some negative signs, things like that. So the first rule that we need to review is the equivalence of radicals and rational exponents. So what that means is a to the 1 over n is equal to the nth root of a, which just sounds like nonsense. So go back to 8th, 9th grade and remember that we had something that looked like this. We called it the square root of 4, and you know that that is equal to 2. Square root of 4, remember that means that there's two numbers, x times x, and when I multiply those together, it's the same number. When I multiply it together, I get 4. And the reason our answer is 2 is because this makes it true. 2 times 2 is 4. Same thing if I said, what's the square root of 9? That means that there's two numbers. Well, there's one number multiplied by itself that equals 9, and you know that that's 3. So the square root of 9 is equal to 3. But we're not only dealing with square roots. This year, we're going to add something in that we call, nth roots. So instead of a square root, which really just means that there's a 2 right here, the square root of 9 is equal to 3, we're going to add something called nth roots. So instead of having two things that multiply to equal 9, now we're going to say, what are three numbers that multiply together to equal 27? So now instead of just two x's, we have to multiply 3 together to equal 27. And our answer would be 3, because 3 times 3 is 9, times 3 more is 27. We also can have, any number in front. I can have the fourth root of 16, which means that there's a number that if I multiply 4 of them together, it equals 16. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2. And we can do that on our calculator. On these calculators here, there's a square root button that you can use. But if you click on math, the fifth option down has an X up above the root. So if you choose that option, it does this really cool thing. It lets you put a number right here. So I can say, what is the fourth root of 81? So what number times itself 4 times is going to equal 81? And your answer is going to be 3, because 3 times 3 times 3 times 3, 4 of those multiplied is 81. So there's your quick recap of what you should have already learned. So there's a rule that says, if I take this idea, if I have a to the 1 over n power, so let's just use an example. If I have 8 raised to the 1 over 3 power, that's equal to, I can take this number on the bottom, and if you look at the example, it moves it into the front of the root. And the 1 just stays right there on top. That just becomes the third root of 8 to the first power. So whatever number's on top stays on top as an exponent. The number on bottom comes out to the front in our radical. Okay, so for this example, a to the 5 over 6th power, the 5 is going to stay there. So that's still a to the 5th power, but the 6 becomes our 6th root. We can move that number that's on the bottom up there into our root. And that's as much as I can do. I don't know what a is, so that right there would actually be my answer. This one, 25x to the 1/2, means, first of all, I guess we better distribute that 1/2. Remember, that means 25 to the 1/2 and x to the 1/2. And 1 over 2 means that the 2 comes in front. So that's just going to be the square root of 25 to the first power, multiplied by the 2 goes in front, the square root of x to the first power, which is nice because the 1s don't really mean anything. And we know the square root of 25 is just 5. So our answer would be 5 square root x. The third example here, we've got a 12 being multiplied out front, which we've got to be careful of because that's just being multiplied. That doesn't do anything. But then I have a third root right here and x to the 4th power. So it just wants me to write something equivalent to this expression. So that 3 that's in the root, remember I can move that underneath the 4. So that can become 12 multiplied by x raised to the 4/3 power. And to me, that right there, that's a great answer. So those are all equivalent. So a few examples. You'll see a lot more on the homework. But let's move on to a new rule. Use the definition of a negative exponent. So if I have a number x and I raise it to a negative number, what's really cool about that is all I have to do is move it to the bottom of a fraction and it becomes a positive number. So x to the negative b is equal to 1 over x to the b. Or we'll go over this example in 1 second. If I have, let's put a number in there, 8 to the negative 2 power is equal to 1 over 8 to the 2nd power, which is just 1 over 64. So if there's a negative exponent, all you do is move the whole thing to the bottom and it becomes a positive exponent. You can also do the same thing the other way around. If the negative is on the bottom, you can move it to the top. So if I have, let's say 1 over 8 to the negative 3 power, to get rid of that negative exponent, I move it to the top, this whole thing to the top, and it just becomes 8 to the 3rd power, but positive. So in this example, a to the negative 4 over 2 times a. I like this problem, except that there's a negative exponent, and I don't want a negative exponent. So this a to the negative 4th, I'm going to move that to the bottom. So all that's left on top is a 1. And now I have 2 times a times, when I move the a to the negative 4th to the bottom, it becomes a to the 4th power. So this simplifies. 1 over 2 times a to the 4th is just 1 over 2 times a to the 5th power. Okay, so that's one way to deal with negative exponents and probably the easiest way. What if the negative exponent's on the outside of a parenthesis? A over b, so we have a number on the inside. Let's say it's 4/3 on the inside raised to the negative 2 power. To get rid of that negative exponent, all you do is flip the fraction over and change it to a positive. So that would become 3/4 to the 2nd power. And then you could simplify and make that 3 squared over 4 squared, which is just 9 over 16. So if the negative's on the outside of the parentheses, flip it over, change it to a positive. If the negative's on top, move it to the bottom, change it to a positive. So dividing powers with the same base. This is just kind of a shortcut to what we were doing last time. What if I have 2 to the 6th on the top divided by 2 squared? So my bases are the same. They both have a 2. In this case, I have 6 2's on top and I have 2 2's on the bottom, which means that I have more 2's on top. I've got 4 extra 2's. So basically what we're doing mathematically is this is 2 times 2 times 2 times 2 times 2 times 2. That's our top. And on the bottom, I have 2 times 2. Well, this 2 is going to cancel. This 2 is going to cancel, which leaves me with 2 to the 4th power on top. The shortcut is I just take the top and I minus the bottom, which is what this formula is telling you to do. You take the 6, you minus the 2, and you get 2 to the 4th power. So for an example, let's say that I have 7 to the 8th power divided by 4 or not 4. We can't do that. What am I doing? 7 to the 8th power divided by 7 to the 4th power. That means I've got 8 7 on top and 4 7s on the bottom. 8 minus 4. I've got 4 more 7s on the top. So my answer is 7 to the 4th power. What if the bottom number is bigger? What if it was this way? What if it was 7 thirds over 7 to the 3rd power, over 7 to the 5th power? In this case, I only have 3 7s on top. 1, 2, 3, and I have 5 on bottom. 1, 2, 3, 4, 5. So when I cancel out, I'm actually left over with 7s on the bottom. So it becomes 1 over, and there's 2 7s left. I can use the same shortcut though. I can do it long way like that, or 3 minus 5 is negative 2. So this becomes 7 to the negative 2 power, which we just learned is equal to 1 over 7 squared. Either way gets you the same answer. I think the easiest way to look at it is, are there more on top or bottom? Look at how many more, and that's what's left over. So let's do that in this example right here. I've got 4 x's on the top, and I have 4 x's on the bottom. So those are just going to cancel out. Those go away. That's nice. I've got negative 1x on the top and negative 1 y's, and I have y to the negative 5th on the bottom. I don't want those negative exponents. So let's use our rule up here to make them positive. So this y to the negative 5th, I'm going to move it to the top and make it positive. And I still have z8 up there, divided by this y to the negative 1. I'm going to move it to the bottom and make it a positive 1. And then I have just 1 z down here. So now let's simplify. I have 5 y's on top. I have 1 on bottom. That means when I subtract, I'm going to have 4 left over on the top. I have 8 z's on top. I have 1 on the bottom. So that means I'm going to have 7 z's left over, if my pen will write, on the top. So my answer is just y to the 4th over z to the 7th. Okay, I know a lot of rules really fast. Let's do some more examples. So I have 12 over 3, and this works because, be careful, everything's being multiplied together. If there was a plus in the middle of this somewhere, if there was a plus right here, we'd be in real big trouble and we couldn't do any of this. It works because there's no plus or minus signs. There's only multiplication. So the 12 over 3, well, I know what that is. That's just 12 divided by 3, which is 4. So I have a 4 left over on top. I have a to the negative 1 on top. I don't like a to the negative 1. So let's go ahead and move that to the bottom. So now I have a to the 1 on the bottom. The 12 and the 3 are gone. I have a to the 6 on the bottom. That can stay there. B to the 8, that can stay on top for right now. B to the negative 1, I don't want negative 1 on the bottom, so let's move that b to the negative 1 to the top and make it a positive. C to the negative 2, again, I don't want negative, so I'm going to move that to the bottom and call it c squared. The c to the 6th is already on the bottom. So now we just have to do simplification. The 4 is still there all by itself. I have b to the 8th times b to the 1st power, which just means that there's 9 b's on top. On the bottom, I have a to the 1st times a to the 6th. That's 7 a's. And I have c squared and c to the 6th. So that's c to the 8th power. So that would be my final answer there. We could, instead of subtracting these, because they're both on the bottom, we combined them together. If I had had some left over on top and some on bottom, let's see if I have an example of that on this next page. I don't. Let's do one more example right here. Let's say that I have 8 over 16, and let's say we have a to the negative 4 on top and a to the negative 7 on bottom. And then let's say we have a b to the negative 8 on top and a b to the negative 2 on bottom. So let's get rid of some of this stuff. 8 over 16, that's just 1/2. So 1 on top, 2 on bottom. Those are gone. A to the negative 4th, we don't want a negative 4th. We want to move it to the bottom and make it a positive 4th. A to the negative 7th, we don't want a negative 7 on the bottom, so we're going to move it to the top. A to the positive 7th. B to the negative 8th, again, I don't want a negative 8. I want to move it to the bottom and make that B to the 8th. And B to the negative 2, I'm going to move to the top, so it becomes B to the positive 2. So 1 times A to the 7th, B squared over 2A to the 4th, B to the 8th. So I have 7 A's on top. I have 4 A's on the bottom, which means there's more on top. There's 3 more on top. So I'm going to be left over with A's on top. B squared on top, B to the 8th on the bottom. I've got more B's on the bottom. I've got 6 extra B's on the bottom. So B to the 6th is going to be left over on the bottom. So those are gone. And I'm left with 1/2, which I'm just going to put the 2 on the bottom. I'm not going to write the 1 because when you're multiplying, a 1 doesn't mean anything. It's just a 1. So that would be my answer there. All right, moving on. Couple more examples. 5d to the 7/2 times 2g to the 5/6 multiplied by 2g to the 7/2 times 5d to the 5/6. This one, you're probably going to see something very similar on the test. Make sure you know how to do this problem and be really careful because there's a lot going on. We have fractions up here as our exponents. We have different letters as our bases. So let's just start multiplying what we can. I have a 5, a 2, a 2, and a 5 out front. So I can do 5 times 2 times 2 times 5, which is 5 times 2 is 10, times 2 is 20, times 5 is 100. So that gives me 100, and now these numbers are gone. D to the 7/2 and D to the 5/6. So I have D to the 7/2 and D to the 5/6. And our rule says that I can add these together. To add fractions, I need common denominators. So let's change this instead of 7/2. Let's change that to 21 over 6. Now I can add these together. So that's D to the 21 plus 5. So that's D to the 26 over 6. And now we've got our G's. I have G to the 5/6. And I have G to the 7/2. And again, I want to add those together. So I've got to change this to 21 over 6. When I add them together, 21 plus 5 means I've got G to the 26 over 6. Simplifies a little bit more. 100 D 26 over 6, that's just 13 over 3. And 26 over 6 is again 13 over 3. So 100 D to the 13/3 and G to the 13/3. If we wanted to, I'm great with that answer. But if you wanted to get rid of the fractions up here, you could change that to 100. Remember, the 3 goes on the bottom. And this would be D to the 13. And here, the 3 is in the square root. And that would be G to the 13th. That's also a great answer. I'd accept either one. Okay? How about this one? 25y to the 4th raised to the negative 1/2. I don't want a negative 1/2. I want a positive 1/2, which means I've got to flip this over. I've got to flip that over. So 25y to the 4th over 1 becomes 1 over 25y to the 4th. And that's all raised instead of a negative 1/2. That becomes a 1/2. So now we got to distribute that 1/2. So I get 1 to the 1/2 divided by the 1/2 goes to the 25. And it also goes to the y to the 4th. So we've got lots of rules at play here. 1 to the 1/2, that's just 1. 25 raised to the 1/2 you can do that on your calculator. 25 raised. Just make sure you put it in parentheses up there so it doesn't do the math wrong. 25 raised to the 1/2 is 5. So that becomes a 5. Y to the 4th raised to the 1/2. Remember, an exponent raised to another exponent. Let's write it a little bit bigger right here. Y to the 4th raised to the 1/2 means you multiply those two together. So that just becomes y. 4 times 1/2 is just squared, is just 2. So 1/5y squared would be your final answer on that one. Okay, are we done? Almost. This one here, again, ACT question that will absolutely be on the test. But let's start with this one here. Y to the 1/2 squared, y to the 1/2 over 6 all squared. I've got to distribute that 2 to the top and the bottom. So that becomes y to the 1/2 times 2 over 6 squared. 1/2 times 2 is just 1. And 6 squared is 36. So y over 36 would be your final answer. Now the fun one. There's a couple of different answers you're going to get on this one. Well, there's only one answer, but it can be in a couple of different forms. And the ACT likes to ask for a very specific form, meaning it does not want decimals. So watch what happens. If I take 24b raised to the 2/3, that 2/3 has to go to the 24 and to the b. So that becomes 24 to the 2/3 times b to the 2/3. B to the 2/3, that's just going to stay b to the 2/3. We don't need to mess with that. But this right here is what causes us a problem, because if I try to put that in my calculator, 24 raised to the 2/3 power is going to give me a big, long, ugly decimal. And it doesn't like that. I can't even get the calculator to give me a nice answer for it. So we've got to do a little bit of work to simplify this problem, because technically this is correct. This is also correct as a decimal, but it wants us to simplify the 24 to the 2/3. And here's how you do it. There's a long, drawn-out process that we're going to ignore for now, and I'm going to show you the shortcut. What this means is 24 to the 2/3. Remember, the 3 can come out front and become the cube root of 24 squared. And then we still have the b to the 2/3. I didn't forget about it. We're just going to ignore it for a minute. So here's the problem. I want to break up 24 into numbers that I know the cube root of. Remember when, let me think of an example real quick. What if I asked you for the square root of 18? That's not a nice number. If I put that in the calculator, second square root 18, I get an ugly decimal. So what we taught you to do was to break this up. We taught you to change it to the square root of 9 times 2, because we know the square root of 9. It's 3. So that 3 comes out in front, and it becomes 3 square root 2, and the 2 stays on the inside. We want to do the same thing with this, but we're not looking for square roots. We're looking for third roots. We're looking for cube roots. So something that you haven't memorized yet. 2 squared is 4. 2 cubed is equal to 8. Remember that. 3 squared is 9. 3 cubed is 27. Remember that number. 4 squared is 16. 4 cubed is 64. Remember that number. What we're looking for is we're looking to break up 24 into, we're looking for what multiplies to be 24. Lots of things. 1 and 24 multiply to be 24. 2 and 12. 3 and 8. 4 and 6, lots of things. So I could break up this 24 into lots of different things. But I'm looking for something that I know the cube root of, which is right there, 8. This one. So what I want to do, just like I did right here with the 9 times 2, and I pulled the 9 out, I want to change this to 24. Instead of 24 squared, I want that to be 3 squared times 8 squared. Because I know that the cube root of 8 is 2. Going backwards, I know that the cube root of 8 is 2. So I can pull that 8 squared into the front and change it to 2 squared of my cube root of 3 squared. I know it sounds messy and it's going to take some practice. 2 squared, that's 4. Cube root of 3 squared. Actually, let's just change that because I know that 3 squared is 9. And then b to the 2/3 power would be your final answer. That's the shortcut. If you can break up this 24 into something you know the cube root of, the 8 and the 3, you can pull it out just like we did with square roots. Sometimes it can be difficult to recognize what the cube roots are, which is why I would recommend you memorize a couple of them. All right. You'll see some problems on the homework that look like this. Practice them, practice them, practice them. It will absolutely be on the test. It will absolutely show up on the ACT. It's one of those common ones that comes up a lot. So homework 2 is your homework assignment. Plan on this one taking a little bit more than the last one. This one's going to take some work. It's going to take some time. You're probably going to need to do some of the problems more than once to make sure that you know what's going on. It's due next class period. If you have any problems, come see me or use that Get Help button, and good luck.